Hey guys, so these are the four equations that I asked you to solve in classwork 3.2.1.b. Feel free, if you got these right, to skip ahead in the videos, the problems that you got wrong. So here we go. So for this first one, you want to isolate what's being squared here. So you want to subtract 6 first, and then you get 3 times x minus 4 squared equals 27. And then you want to divide everything by 3. And then you get x minus 4 squared equals 9. Okay, so now that we've isolated what's being squared, now we can square root it to untrap x. And then we get the absolute value of x minus 4 equals the square root of 9. And then from there, you want to make two equations. So the first one is x minus 4 equals positive 3, which is the square root of 9. And then x minus 4 equals negative 3. And then you add 4 to both sides, here and here. So you get your first answer is x equals 7, and the next one is x equals 1. And those are your two answers. Okay, and then for this one, you want to get rid of these fractions. So you want to multiply something that will get rid of the 4, 5, and 20. So you want to multiply everything by 20 because 20 is divisible by 4, 5, and 20. And then you get x plus x. So all the denominators will, and then you multiply 20 by each of these. So you want to multiply 20 by this first one, and then you do 20 divided by 4, and you get 5 times x. And then you multiply 20 to the next one, and then you do 20 divided by 5, which leaves you with 4 left over. And then lastly, 20 divided by 20 is just 1. And then you multiply those. So then you get 9x plus 4x equals 9x minus 4. So that's 13x equals 9x minus 4. And then subtract 9x. And then you get 4x equals negative 4. So x equals negative 1. And then for this one, you want to get rid of this dividing by 2. So multiply everything by 2. And you get 3 plus 10 minus 3x. Oops. JK. Get 6 plus 10 minus 3x equals 10. And then that's 16 minus 3x equals 10 when you combine the 6 and the 10. And then subtract 16 from both sides. And then you get negative 3x equals negative 6. So you get x equals 2. Okay, now for this last one, just kind of like this squared one, you want to isolate the square root. So subtract 4. So then you get negative 3 times the square root of 2x minus 1 equals 6. And then you divide by negative 3. And you get the square root of 2x minus 1 equals negative 2. And you'll realize that you have a square root equaling a negative number, which is not possible. So, no real answer. Okay. Now, moving on. Okay, so it says solve the following systems. So you need to solve this both algebraically and graphically. So first I'm going to take this. So algebraically, you can see they're set up to solve by substitution because you have y all by itself here. So you plug it in here, and then you get 4x plus 6 times negative 2/3 x plus 7 equals 42. And then that's 4x. And then you want to distribute this 6. So then you get negative 4x plus 42 equals 42. And then you'll notice these go away, and you get 42 equals 42. So the answers are all real numbers, because 42 does equal 42. So if you got an equation with just numbers and you got like 0 equals 4, then it would be no solution because that isn't true. But 42 does equal 42, so all real numbers. And on the graph, it means they're both the same line. So if you graphed both of them, a y-intercept of 7, a negative 2/3, you go down 2 over 3, down 2 over 3, and there's my beautiful line. Okay, so next problem. So this one, they're both equal to y, so I would set them equal to each other to solve for x. So then you have x plus 1 squared plus 3 equals 2x plus 4. Okay, and then you want to expand this, right, using an area model. So that's x squared plus 2x plus 1 plus 3 equals 2x plus 4. And let's just simplify this left side. So that's x squared plus 2x plus 4 equals 2x plus 4. And then if you set it, since it's a quadratic, you'd want to set it equal to 0. But it just so happens that you can see that, well, a lot of stuff goes away. And then you get x squared equals 0. So when is x squared 0? When x is 0. So that must mean, right, that you have a intercept at 0 something, and then to find what that is, you want to plug that into either of these equations. So if I plug it into this one, which was over here, then it'd be y equals 2 times 0 plus 4. So then you'd get y equals 4. So then the point of intersection is 0, 4. And then if you graph them, like if this one, then that has a vertex of -1, 3, and then it has this point, this point. So here is this parabola. And this line has a y-intercept of 4 and then a slope of 2. Oops. So there you go. And there you can see, like, there's your point of intersection at 0, 4. Just like box these answers. Okay, next problem. Okay, so this one's another a system of equations. And again, they're both equal to y, so you should set them equal to each other. Okay, and then I probably get rid of this fraction. Ooh, multiply by 7. And then you get -21 x minus 4 squared minus 14 equals -4x plus 28. That's a lot easier, I think. So let's just add 14 here. And then just to consolidate a bit, because I have to expand this x minus 4. So then that's -2 plus 42. And then I need to expand this here. So then that's -21 times x squared minus 8x plus 16 equals a -4x plus 42. And then you distribute this, plus 168 x plus minus 336 Okay, and then you want to subtract 4x and 42. And you get 164 minus 378. Turns out that if you graph this one as a vertex of 4, -2, and then you graph this one +4, and then -4/7 is down 4/7. Turns out they do not intersect. So the answer is no solution. So if you, though this does not factor, so write that here. Okay, so does not factor. And so if you use the quadratic formula, what happens is you'll get like a negative underneath the square root, right? Like if it's this negative e plus or minus b squared minus 4ac all over 2a, you'll get a negative here. And that's how you know that there is no solution. But obviously, graphing here shows that there's no solution a little bit better. Okay, now let's do these ones. So this one, nicely, they're all aligned. So that one has a y-intercept of 6 and a slope of 1/2. Okay, and then because it's less than, right, it's dotted in below. So we connect them with a dotted line, which I clearly could use some work drawing. Okay, and then below, so I just like make a little arrow. Ooh, that is not the best. Okay, and the next one is negative 1/2 x plus 6. So has a y-intercept of 6, but then it's negative 1/2. And again, you need to connect dotted. I think I'm just going to do this. Fancy. Oh, that was... Okay, and so it needs, because it's greater than, it's dotted, but above. So then that goes here. And then this last one, it's x is less than 12. So you want to find 12 on here. 1, 2, 3, 4, 5, 6. Okay, so then that's dotted. Oh, weirdly, I just like drew my arrows over there. Dotted. And then where's less than 12? To the left of 12. right? The x values that are bigger than 12 are over here on the right, whereas the smaller ones are there. So then the overlap of everything, right, is in this region. So that's the solution there. Okay, and then this one, to probably solve for y first. So subtract 3x. So you have negative 3x plus 12. And then divide by 4, you get negative 3/4 x plus 3. So you graph that, and that's going to be dotted in below. So down 3/4. And then shade below. So make little markings. Okay, and this next one, like, is a parabola that has a vertex of -1, -4. And then this one is dotted and above. So and then above is like here. So you can see the overlap is in this area. So that is the solution. Okay, next one here. So this one, the vertex is at 1, 6. And here's other points. Oops. Oh, I did that right. Okay. So, and this one is going to be dotted in below. Oopsies. I wish there was an undo button on this thingy. And so below is like this. And this one, other one is greater than x minus 7. So again, dotted and above. So x minus 7 is here. And then that's a slope of 1. So it has a y-intercept of -7 and a slope of 1. think I lost track of my points here. Okay, and then this one's above. So that's here, and then you can see what happens is, again, this region, enclosed region, is the overlap. Okay, last couple of problems. Okay, so you can see like this one is a line, and you just want to see like, okay, it's shaded below the line and it's solid. So it's going to be y is less than or equal to. And then you just need to find the slope and the y-intercept. So the slope looks like it's to the right 3 and up 1. So it's 1/3 x and has a y-intercept of 4. Okay, and then this one. So this one, you can see the shaded region is below the line. And so it's y, and it's solid, so it's y is less than or equal to. And then you just need to find the slope and the y-intercept. So the slope looks like, goes down 1/1. So it looks like the slope is negative x, and it has a y-intercept of 8. And then this last one, you can see the shaded region is above this line. So then this one's going to be y is greater than or equal to, because the line is solid. And then it looks like the slope is down 1/2, so negative 1/2 x with a y-intercept of 4. Okay, and then for this one, you can see there's this parabola where it's shaded above, and it's a solid parabola, so it's greater than or equal to. And then the vertex is right here, which is 6, -5. So it'll be x minus 6 squared minus 5. And turns out the a value is 1, so you're good. And then there's also this other boundary here, right? And it's shaded below this boundary, and that's just a horizontal line. So then that's just y, and then looks like it's solid, less than or equal to 0. So that's it. Thanks for watching my video.